Today I want to talk about building a flagpole antenna, and what I'll give is the steps to build the flagpole antenna and the material list of what will be required of everything except the mounting of the antenna to the ground, which will depend on what you want as your QTH. So it may be different depending on what your objectives are and the reason for having the flagpole antenna. But anyway, why would you want a flagpole antenna? Let's say you live in a area that has zoning restrictions or something such as that, where you can't put up a standard ham antenna vertical, or you live, let's say, in a HOA where they don't allow such things, which, that's pretty common today. Or it could be your significant other, your XYL, said, no, you're not putting an antenna in our yard. I'm not going to look at that thing. So there may be multiple reasons that you have a need for a flagpole antenna. So let's talk for a minute about flagpole antennas. You can buy them online complete, or a complete kit, for around $1,200, which includes the antenna tuner that you see right here, the LDG, what is it, the RT100, I think it is, antenna tuner. So for about $1,200, you can get the kit with the antenna tuner, or for around $1,000, you can get it without the tuner. So there are some out there, but if you build one yourself, if you have the ability and the desire, you can save a significant amount of money by acquiring the materials and doing it yourself. So what are you going to need? Here's a list of what you're going to need for the most part. You're going to need a flagpole, and we'll look at the one that I purchased here in a minute. This was one that was reused. I did this as a trial just to see how it would work in case I have a need, which there's a potential that I could have a need for it sometime in the future. But I'll show you in a minute the flagpole that I bought. You're going to need, for this type of antenna that I'm going to show today, you will need a tuner. You will, some type, a remote tuner that's at the feed point of the antenna. So this one right here actually works very well, the LDG antenna tuner. You're going to need some self-tapping sheet metal screws. You're going to need some wire for radials. I have radials in my yard. You're going to need, if you desire, some structural foam, and I'll tell you what that's for in a little bit. And you may need some PVC for mounting your antenna to the ground, and we'll talk a little bit about that. You may want PVC, or you may want something else. But let's talk about material cost. We said already that you can buy one online, a kit online that you install yourself, for anywhere from $1,000 to $1,200. Well, this right here, this pole that I bought this off of Amazon for right at $100. It's an aluminum heavy gauge flagpole, and let's see if I can find the pole itself. A picture of the pole itself. Stand by. And we got helicopters coming over. So this, if you can see it for the glare, this is the flagpole that I bought. 25 feet tall, $99. I bought that flagpole. What else did I get? So the flagpole was $100. The remote tuner that goes at the antenna feed point was right around $300, so that's 4. I bought some structural foam. This structural foam right here. This is a dense 6-pound structural foam, expanding foam that you mix, and it fills the flagpole. And I'll tell you why I did that. Although I had confidence that the flagpole would support what I was doing previously, I wanted to make sure that I could add some rigidity to it without adding weight. So I used the structural foam for that, and we'll talk about how I did that in a minute if I remember. You're going to need the structural foam, by the way, was about $70 off of Amazon. Wire, my yard has a radial field already. You're going to need about maybe at the most $30 worth of wire. $5 worth of self-tapping sheet metal screws, 1 for each section to hold the sections of the flagpole together. And some PVC, if you choose to use PVC for the base of your antenna, which I chose to do in my trial. So total cost for what I have right here, including the pole and the antenna tuner and the foam, is right at $500. So you're $500 to $700 less than it would cost to buy one online. Now this is set up as a vertical, where the one you can buy online is, I believe it's set up as an off-center fed dipole. But then you ask, well, what kind of a conducting element is the flagpole going to be? Is it going to work good? Well, computer modeling showed that I averaged it to a 1.5 inch diameter aluminum pole. It's 1.5 inch at the top. It's 2 inches, actually 2.05 inches at the bottom. So I did the modeling, and it showed for 40 and 20 meters, the radiation pattern for a pole this diameter was very similar to the radiation pattern of a quarter wave at 40 and a half wave at 20 meters using this pole. So the radiation patterns were very similar. So it should work according to what the computer models say. Now let's talk about what I had to do to get this to work in my case, and why you may want to do something else. This PVC is 2-inch Schedule 40 PVC. Inside diameter is 2.04 inches. The flagpole, 2.05 inches. So we got a problem here, folks. It's not going to work, but this can be overcome. There are several ways to do it. I'll tell you what I did to run my test and see how it worked. Was I took a heat gun and I heated the PVC so that it was flexible. But first thing I did was I cut a slit down the PVC right here, starting right here, and I cut it down about 20 inches. So I have 20 inches of flagpole inside this PVC. And then I used hose clamps just to hold it together. It's very secure, it won't come apart. But if I was going to do this permanently here at my QTH, what I would probably do if I knew it was going to be permanent, I would heat the PVC to a point where I could shove the pole in 18 to 20 inches, and then I would let it cool, because the problem that you face is that when you heat the PVC and it stretches, when it cools it contracts. You cannot get this PVC off of this pipe once it cools without putting the slit in there. Don't ask me how I know, but I wrestled with that. So you can do that. I think if I were going to do this permanently, what I would do is I would take and get some pipe hangers, heavy duty, heavy gauge pipe hangers, and I would bury a 4x4 maybe 3 foot into the ground with 2 foot above the ground, and then I would take the pipe hangers and screw to the 4x4, and then use the pipe hangers to support the antenna, such as this, by just the pipe hangers would clamp around the antenna. Then you could use the pipe hangers as your support to raise and lower the antenna. Keeps it from being so unwieldy. And it would pivot down, holding the base. You loosen the top one or the bottom one, whichever one. You leave the other one, and you could just pivot it and lay down the antenna if you needed to. All right, what else did we do? So we fit the PVC to the pole. Also, what I did was, and we may come back to this again, once the PVC was fitted to the pole and I knew it would work, before I put the clamps in, I drilled a hole in the PVC here. This is where you hook the center conductor of your coax to the pole. So you have to come up with a method to do that. What I did with mine is I used it just like I do my spider beam here. I come out of the antenna tuner, I come to a bolt right here, and with my spider beam, this goes up as a wire element. In the case of the flagpole, what I did was I just used this to connect to this wire right here. So that was how I made the flagpole the radiating element, and it worked very well. You just have to pre-drill your hole in the PVC. Then once you get your pipe to where you want it to be, you drill a hole in the aluminum. And you use a self-tapping screw to attach your wire to the pole. So that works real good. Let's talk about the structural foam in the paint pole. If you want structural foam in your paint pole, you have to do it a section at a time. And the reason why is because you can only pour foam to the point that it expands to a 13-inch depth. If you don't allow enough room to expand, then it doesn't set up properly. That's what they say. So I had to pour each section at a time, 2 or 3 pours per section. I got about 12 or 14 inches with each pour, and the pipe does get hot. Plus, if you try to do it all at once, you may have some kind of a blowout where your sections of the pole separate. So you have to do multiple pours of each section, one section at a time. What else? After getting it all put together, I did a continuity test from this end to the next section, and there was no electrical continuity. Now, from a point of RF, it probably wouldn't matter because it doesn't necessarily depend on an electrical connection anyway. We know RF travels down the outside by the skin effect. So, but just for insurance, for each section here, I drilled a hole and put a self-tapping screw so that there would be continuity between each section. So all the way up, I did the drilling of a hole and putting self-tapping screws in there. So I've got RF and electrical continuity the complete length of this pole. All right, so as I said, we did that. I had a hole in the PVC for the feed point and such as that. So next thing to do is you have to set your pole. Now again, that depends on what you're going to do. The pole cannot be in contact with the ground. What I have here is I have approximately 8 inches of space between the bottom of the flagpole and the end of the PVC. So when I raised this one, what I did was, well, I'll come back to that in a minute. If you're going to do it like that, that's fine. You can use pipe hangers or whatever. If you're going to use just PVC, what you may do is get your foam to the length that you want it, to the size so that the pipe fits in, and then take the PVC and one section of the flagpole and set your PVC into the ground at least 3 feet deep. You need to go pretty deep with that. But the flagpole has to be, the base of the flagpole has to be above ground level. You can't have that below ground level. So again, what I would do, I think if I were going to do this permanently here at my place, I would use pipe hangers and attach pipe hangers at least 2 points here after setting a 4x4 in the ground, and use the pipe hangers to keep the bottom of the flagpole off of the ground. And in that case, I wouldn't have to use PVC at all. I would just use 2-inch pipe hangers, which would work fine. So that's the point that you're going to have to decide, how do you want to mount this? I'm sure everybody has an idea on how they can raise a flagpole, but the flagpole is very light. I don't think it probably weighs 7 or 8 pounds. The foam added no weight to it. You can with one hand manipulate the pole and raise it up and down and such as that. What else do you do? After you do that, you got to lay your radials. It does require radials for this setup. So you lay your radial field. After you did that, you would connect your radial field to the ground on the antenna tuner. What I have 24 16-foot radials in the yard, and I get an awesome ground with that. It works really well here at my QTH. So after that, what else do you do? Of course, you have the antenna tuner, so you have to hook that up per instructions, so you can get a tune on the flagpole, and it will tune. Once you do that, you can get on the air. Now, I have already taken down the flagpole, and I've put my wire antenna back up. and I intend to keep the wire antenna up at this time. But the flagpole was tested just in the event that, given I do live in an HOA, if somebody said, well, sometime I got to get rid of my spider beam, well, then the flagpole goes up. So I've got options. What else is there? I think the next thing is, somebody's going to ask, well, what kind of results do you get? Computer models are one thing, but what kind of results do you actually get when you try to get on the air using this as your radiating element? And oh, by the way, mine is 24 feet 4 inches long. Using this as a radiating element and using your radials for your ground. So does it work? Well, let me tell you, this is a DX antenna. Let me show you. So after I hooked this up, when nighttime came, let me see if I can get the glare off of the screen. I made contacts with Connecticut, which does not show, the Dominican Republic, 2 Bulgarian contacts, and a contact in Spain. These are people that I talk to on a regular basis, and for Bulgaria and the Dominican Republic, I got the same signal level that I always get with a wire antenna. I got the same thing with the flagpole. So it is a DX antenna. The results from Spain showed me down about 1 S unit. Was it propagation at the time? You know, propagation and band conditions have not been the best recently. So it could have been just propagation to Spain that night, but I know that Bulgaria and the Caribbean gave me the same reports. Dominican Republic 5.8, Bulgaria 5.8, Spain, that was my low one, it was a 5.5, and that's using 100 watts with a Yaesu FT710 and the flagpole as the radiating element. It does work. It does function as a DX antenna, which is what I wanted to know. Now, if you have a need for a flagpole antenna to be discreet, to be incognito, whatever you want to call it, they will work. I like the structural foam in mine because it makes it rigid without making it heavy. I would put the foam again. The foam is not cheap. That was it right there. But it was well worth it. Previously, I had the antenna being used for an antenna mast, or the flagpole being used as an antenna mast for UHF, VHF, and I had a 3-pound antenna on the top, and this flagpole withstood 70-mile-an-hour winds. So if you're using it just as a antenna with nothing on top, then you should have no problem. One thing I did think about was, if I use this as an antenna, then what I could do is possibly put a dipole on top and use the vertical as a transmit antenna and the dipole as a receive. I don't think I showed this. Let me show you where I had this set up for testing, because I did take it down. I had it set up right here. The flagpole is heavier than my spider beam, so I had about 6 bungees around it. But it's tied. It was tied to a farm fence post right here, and that metal. I did have standoffs so that the flagpole did not touch the post, but I had no problems, even though this metal was running parallel to the flagpole, and even though it went into the ground. So The flagpole was about 6 to 8 inches off the ground, sitting on this block right here. My ground radials come up right here. Again, the flagpole was here. It's just been taken down, but it worked. It was a excellent DX antenna. Was it a little bit less efficient than the wire? Maybe, maybe not, but you know, it's one of them things. How do you tell when it's no more than an S unit? Is it band conditions, or is it trying to use something for a antenna that it was not designed to be an antenna? Just, I'm sure somebody out there can give us an idea on what an increased diameter of a radiating element does for signals. I've looked it up and read about it, but I don't remember what it said. It seems like a larger diameter radiating element gives a broader bandwidth. And even without the tuner, this thing was almost resonant on 20 meters. I think it was running a resonance at about 14.5 megahertz. So it was pretty close already on 20 meters. But anyway, if you got any questions, put them in the comments. I'll try to answer. If you like this video, think about subscribing, share it with somebody else, post it online somewhere so it can help people out. These flagpoles are on sale for $99 and I get nothing from it, but it's a good deal. They're good poles. So again, think about subscribing, share, and until the next video, take it easy. Bye-bye.